Okay, today we're talking about more transformations. We're talking specifically about reflections, and then we're going to do a little bit of rotations, but we'll do that more in class because those are a bit trickier. So in your notes packet, once again, we're referring to the pink one. If you have it, here's where it's going to start to get tricky if you don't have the notes packet, because we're going to be dealing with a lot of graphs. And so you're going to have to be copying quite a bit of graphs onto your own paper if you don't have the packet with all of them in it. But all of the example numbers refer to the numbers in the packet if you happen to have it. So a reflection, just to recall, guys, is flipping over a line or an axis. What we want to think about is that line or our axis is like our mirror. What we're going to do when we do this is we're going to count how far away we are from the mirror, and then plot the point on the other side the same distance away. Because you guys know when you're looking at yourself in the mirror, when you're standing up close, you look big in the mirror, right? The farther away you get from the mirror, the smaller you get, right? It's like your image is standing the same distance away from the mirror as you are, right? The closer you are, your image is right there. The further away you are, your image looks further away. So we're going to count how far away our picture is, our graph is, from this mirror and flip it over that the same distance away. Now, sometimes the mirror is the y or the x-axis. We're trying to reflect over the y or the x-axis. However, sometimes it's a given line and we need to refresh this. So have this written down. If you have your pink packet, write this down here at the bottom because this is not in the notes here. So at the bottom, please write, if the line is y equals a number, that's what this means. So if it says like y equals 10 or y equals -2, that line is, if you guys can recall this from Algebra 1, if I have y equals a number, that line is horizontal. Now this is weird to us because we normally think the y-axis, and that's correct, the y-axis is the vertical one. However, y equals a number is horizontal because every single point on that line has the same y value. If I have a line y equals 3, every single point there is going to have that same value of y equals 3. So even though the x-axis is horizontal, x equals 5 or x equals -4 is going to be a vertical line. So please make sure you have that written down here at the bottom. If you want to add a reminder to yourself that the x-axis is horizontal and the y-axis is vertical, that is different from these ones, so we got to be careful there. Okay, so let's look at our first example here. So this is once again example 1 in your pink packet for 5.2. So we want to reflect DE over the y-axis. So to start with, y-axis, the y-axis, is that the vertical line or the horizontal line? That is the vertical line. The y-axis is vertical. Remember, y equals a number is horizontal. And this is not y equals a number. This is just the y-axis. So what that means is this is our mirror. We want to count how far away each point is from that mirror and then plot that point on the opposite side the same distance away. So what we're going to do here, now real quickly, I'll just do this actually. If you do not have your notes packet, you'll want to copy this onto your paper. I will give you the points for D and E, so you can plot it carefully on your paper if you can't quite count it. So D is 1, 2, 3, 4, comma 1, 2, 3, 4. And E is 1, 2, 3, 4, 5, 6, 7, comma -3. So if you do not have your notes packet, draw a little graph yourself and plot those points, connect the dots, and then you can go from here. Okay, so once again, we have said y is our mirror. We're going to count how far away D and E are from our mirror, and then we're going to flip it over that the same distance away. So you're going to count straight towards your mirror. So D is 1, 2, 3, 4 points away. So D prime, remember that's going to be how we say the new image. D is the first image, D prime is the new one. also needs to be 4 points away on the other side. So we went 1, 2, 3, 4 to our mirror. Our new point is going to go 1, 2, 3, 4. So here is D prime. So we're going to do the exact same thing for E. So go ahead and count how far away E is from the y-axis. Excuse me. I sneeze a lot. Oh my gosh. Okay, try it again. Count how far away E is from the y-axis. How far is it? Let's count. We got 1, 2, 3, 4, 5, 6, 7 away. So I need to put E 7 away on the other side. 1, 2, 3, 4, 5, 6, 7. There is E prime. That's our new image of E. We can connect the dots, and this is my answer. That is the reflection of DE across the right axis, and we would call, the y-axis, and we would call this D prime E prime. So once again, we count away from our mirror, we count towards the mirror, and then count away the same distance on the opposite side. You don't have to put all of these little dots, right? They're not part of our answer. Just the line D prime E prime is a part of our answer. That just helps me count. But you don't have to put those dots. Okay, let's try it again. So this is now example 2 in your packet. It's the same DE. However, whoops, I typed this wrong. We are now reflecting across the x-axis. So find your mirror. Where is the x-axis? That is the horizontal line. If the y-axis was vertical, x-axis is horizontal. Now this one's a little bit weird because our mirror cuts through the shape we need to reflect. How this works still, we still count towards our mirror in both cases. So for D, I'm going to count down to the mirror. For E, I'm going to count up to the mirror. Once again, the points for D and E are the same. So if you do not have your pink packet, draw this graph again, draw DE again, plot those points on your own little graph. Now we're going to reflect over the x-axis. So tell me, here's D. I'm going to count down to my mirror. How many points is D away from the x-axis? Let's see. D is 1, 2, 3, 4 points away. So D prime is going to go 4 points away on the other side. 1, 2, 3, and 4. Here's D prime. Now E is up here. I am once again going to count towards the mirror. We always reflect over the mirror. So how many points away from the x-axis from our mirror is E? 3. We have 1, 2, 3. I count 1, 2, 3. There is E prime. So again, don't get confused by all these dots. We don't need them. They're just to help count. What we do need to do, let me make sure that I put this right. 1, 2, 3, 4. 1, 2, 3, 4. There we go. What we do need to do is we need to connect the dots. So that new line is my answer. And once again, we would call that line D prime, E prime. I hope this is making sense. So when your mirror, just to kind of sum up here, when your mirror cuts through your shape, you're going to end up kind of overlapping the shape when you reflect it. Notice how these lines cross. That's going to happen if your mirror goes through the shape. Okay, now we're going to try a little bit harder one because we're going to reflect across a line. So look back to what you wrote down. You should have copied it down. This is y equals -3. Is this going to be a vertical or a horizontal line? This is horizontal. Yes, I know the y-axis is the vertical line. But y equals -3 is a horizontal line through the point y equals -3. So once again, we still have DE. I'm going to find where y equals -3, which is 1, 2, 3. That is the point where y equals -3. Let's draw a line through that. So this is my mirror. When you are drawing your graphs free-handed, you have to be very careful to keep straight. What is your mirror and what are just the y and the x-axis? So I might recommend to draw this line in a different color on your own paper. If you don't have the notes packet, again, I warned you guys, it was going to be easier if you had this. Because we want to count towards this line. Do not get confused. This is no longer our mirror. This line is our mirror. So we count down to our mirror and then away. Tell me, how far away is D from our mirror? Let's count it. We got 1, 2, 3, 4, 5, 6, 7. I count away. 1, 2, 3, 4, 5, 6, 7. There is D prime. Now for E. This is kind of a trick question. I want to see if you can figure it out. How far away is E from our mirror? It's not far away at all. In fact, it's touching our mirror. This is like if you put your finger on your mirror and it looks like you're like touching like this. Yeah, your reflection would look like you're touching your own finger. What that means is E prime actually stays put. It's actually the same point as E because it's like your fingertips touching. Yeah. If you touch the mirror, it's like you're touching your reflection. So here is our new line. That's our answer for D prime, E prime. If you touch the mirror, that point doesn't actually move. Okay, we got one more example here that we're going to try. Same thing, still the same DE as normal. Again, if you're doing your notes on your own piece of paper, you want to copy this graph fresh every single time. Reflecting DE across the line, x equals 1. So is this a horizontal or vertical line? Vertical. It is vertical through the point x is 1. So find in your graph where x equals 1 and draw a vertical line through it. Take a moment to do that. Okay, here's where x equals 1. Here is the line, x equals 1. Every single point on that line has an x value of 1. Now, once again, I'm going to have you try this all on your own. This is my mirror. Do not count to the y-axis. This is my new mirror. How far away is D? How far away is E? Plot them on the other sides. Go ahead and try it. Okay, let's see if we got this. D is 1, 2, 3 away from our mirror. So I count away 1, 2, 3. Be very careful that you plotted that correctly. From the mirror, we count away 1, 2, 3. So I end up being only 2 away from the axis, but that doesn't matter. I'm looking at my mirror. 3 away from my mirror, 3 away from my mirror. E, we have the same thing. 1, 2, 3, 4, 5, 6 away from my mirror. Now on the other side, same thing. Counting from here. 1, 2, 3, 4, 5, 6. There's E prime. Okay, so hopefully we're understanding how these reflections work. The key thing is to count to the mirror and away. To the mirror and away, however we need to do that. Okay, so for this last piece, I'm just going to give you a chance. I'll pause the video. You want to copy these down. We're going to do the rotations in class because they're a little bit trickier. But if you have your pink packet, at the bottom of the page where you have example 5 and 6, there's a pretty decent chunk of space there. Go ahead and copy these formulas. We'll need these for rotations. Be very careful, guys. If you do not copy these correctly and you accidentally miss a negative sign or you don't write it the correct way, you will have the wrong formula and you will get it wrong every time. So take a moment, pause the video. If you have your pink notes, copy it there at the bottom of the page where you see example 5, example 6. If not, just copy it onto your own piece of paper. Okay, so again, we're going to practice these more in class. Especially with the rotations because they're a little bit different. Hopefully this is making sense, and I will see you guys in class.